This is the second out of 4 videos on the normal distribution. Now this one's going to be a little bit different. This is going to talk about percentile. Now, here it says the speeds of all cars traveling on a stretch of highway 5 are normally distributed. So we know it's normally distributed with a mean of, 55 and a standard deviation of 12. So 55, standard deviation of 12. So what we're going to do is we're going to use our template here. A template has the percentiles on the bottom here, percentiles down here, which matches the z-scores, which all these problems have. And we also have each segment of the normal divided into pieces, so that we know how much, what percent is shaded underneath. So here we have 55 as the mean, and then 12 would be 6, so 12, right? 67, another 12, 7, 8, 9, 6, 7, 79. Hopefully that's right? 5, 6, 7, 5 and 6, 7, 8, 9, 6 and 7. Okay. Then in 55 minus 12, that's give you 3, 43. And subtract 12, 131. Okay. Well, pretty sure that's right. Okay. So that gives me an opportunity to estimate the problem. So what is it? What do they want? They want cars who receive a ticket are ranked at the top 2.5 percentile. Okay, 2.5 percentile is right here. This piece right here. That is the top. So right here, and then this of course keeps going, but this is the 2.5 percentile. This is the shaded piece. The top now. That's very important. Now, on the calculator, though, there is a inverse normal. Inverse normal, okay? And there's probably not inverse normal, something like that. The inverse normal will give you the answer that you want, because in this case, if we're estimating, right, they want the expected speed. What is their expected speed? And their expected speed, if it's at the 2.5 percentile, it's going to be 79 or greater, right? Because those that are above 79 or greater, they get a ticket, right? Expected, or receive a ticket. So the inverse normal is a function in your calculator that allows us to calculate what this number is. The way the TI-83 is managed, it's that the percentile is the area below. So the area below, the way it's managed, we're gonna use something like yellow. So this area here, and that's too big. This area, all this area here, is what we need to tell the calculator in yellow. We need to tell it because it's the inverse normal is shading to the left. And that has to do with the tables back then, how you would add the cumulative values of these probabilities. And in this case, we're adding values from negative infinity all the way up to, in this case, it's going to be 2.5, or yeah, up to 2.5. So to calculate this, we're going to have to tell it that it's going to be 0.975, which is the yellow piece. We got to tell the calculator, you need to shade from negative infinity all the way up to 0.975 percentile, with a mean of 55 and a standard deviation of 12. And what it's going to do, it's going to do the reverse of the normal CDF. In this case, it's going to show us a value very close to 79. So we're going to go here, and we're going to try to do this. I'm going to clear second bars. Inverse normal is number 3. And here we do the, here we're going to find the percentile from the left. Okay. That's how this is built on the TI-83. Some other calculators I've seen will be, like, what's the tail, right? I think that's what it is. It says the tail to the left, to the right, or from the center. And this one, the tail is going to be from the left, because we shade from negative infinity to where it stops. In that case, it's 0.975. Hopefully that makes sense. Comma, 55, comma, 12. Close. Enter. There it is. So we get an answer of 78.519. So that means that cars who receive a ticket are expected to be speeding at or above 78.519 miles per hour, right? So we said 79. That was my estimate, right? My estimate was greater than 79 miles per hour. But when we took it to the calculator, it's 78.519 miles per hour. So those cars that receive a ticket are at or above 78.519. And of course, that's an estimate. So this is a more of a percentile type problem. And you'll see this as well. Okay, so let's do the next problem.